present you work example for gamma distribution. The formula for gamma distribution is Fs equal to 1 over beta, the power of alpha. This one symbol for integral in bracket alpha close bracket s alpha minus 1 e the power of negative s divided by beta, and then for s greater than 0 and alpha greater than 0 and beta greater than 0, where the symbol of the integral alpha denotes the gamma function for alpha greater than 0, which is integral equal to integral is 0 into infinity s alpha minus 1 e the power of negative s ds, and the mean for and variance for the gamma distribution is the mean alpha multiplied by beta variance alpha multiplied by beta squared. Then if the alpha is integer, integral alpha equal to alpha minus 1 factorial, the symbol for factorial. Then this is example question for gamma, which is, let's say in the physics class, professor create a model to calculate the cumulative of probability that the classroom that we in, the student in, the temperature will increase after the exam. The model is the gamma distribution. This one is for the gamma distribution. And then let's say the temperature before the experiment is 1.8 and the after experiment is 2.8. And then the experiment which is 1.8 into the 2.4 degrees. This is the formula for the gamma. And then you use the formula, and then the data this here, we substitute the formula into this data, which is Fs 1 minus beta equal to 2. Beta equal to 1, alpha equal to 2. And then we substitute this data into here, which is 1 over 1, beta equal 1, alpha equal to 2, integral alpha 2, s 2 minus 1, which is e negative power of negative s over 1, which is, we solve this function and become this one, s1 e the power of negative s, which is s greater than 0, and then we use the data and we substitute the data like this. F 1.8 less than greater than 1.8, s less than 2.4, and then we use integral 2.4 1.8 s. This one we take data here and then we plot here, and then we use this data integral of 2.4 1.8 multiplied by e the power of the negative s ds, where the symbol, this is for formula from the top. As you can see, this formula is same as in this symbol. Use integral, the symbol for integral. And then to solve this function, use the integration by part, which is f u dv equal to uv minus fv du. We do not use f u du v because this v du is easily to simplify. And then let's say the u equal to s, dv equal to e the power of negative s ds, du equal to ds, v equal to e the power of negative s. And then we substitute this data into this formula. We get this data from here. And then we substitute the data, negative s, e the power of negative s, close bracket, 2.4. This one is because this gamma is integral. We must solve the solution like integral, which is 2.4 1.8 integral 2.4 1.8 minus e the power of negative s ds. We just substitute this data into this. F is equal to the integral of 2.4 and 1.8, and the answer is close bracket negative s e the power of negative s close bracket 2.4 1.8 minus And then we simplify this function and to this function, which is e negative s. This one for integral 2.4 1.8, and then this one you're almost done, which is we substitute 2.4 into this 2.4, and then after that we substitute 1.8 into this, same with this function 2.4 1.8, which is negative s negative 2.4 e the power of negative s, which is 2.4 negative 2.4 close bracket minus close e this one negative s which is negative 2.4, and then close bracket close minus, and then use this situation same as 1.8, which is close bracket negative 1.8 multiply by e s 1.8 negative the power of negative 1.8 minus this e negative 1.8, which is same with this previous function, and then we get the answer, which is 0.19154, which is equal to 50.4% of chance gamma distribution increase between 1.8 and 2.4. And then this answer for all the question. And then if you want to search for the mean and variance, which is mean alpha multiplied by beta equal to the 2, variance x alpha multiplied by beta 2, alpha equal to 2, beta equal to 1. We just substitute the number into this function, and then we get the answer for the alpha for the mean and variance. That's all for us. Thank you.
In a certain city, the daily consumption of electric power in millions of kilowatt hours can be treated as a random variable having gamma distribution with alpha equal 3, beta equal to 2. If the power plant of this city has a daily capacity of 12 million kilowatt hours, what is the probability that this power supply will be inadequate on any given day? To solve this question, we know the x random variables distributed with gamma function, because he said in the context of the question, the alpha equal to 3, beta equal to 2, to find the probability that this power supply will be inadequate on any given day, that is mean the daily consumption of electric power will be greater than 12 million kilowatt hours. Then the probability of x greater than 12 equal to the integration from 12 to infinity of gamma distribution function dx equal to, because the x greater than 12, then the probability of x from 0 to infinity equal to 1. We know that from the probabilities of the distribution function, of the probability of function. Then the integration from 12 to infinity for gamma distribution equal to 1 minus probability of x less or equal 12. Then equal to 1 minus the integration from 0 to infinity of, we substitute in gamma function the value of alpha and beta, then x power 3 minus 1 times e to the minus x over 2 power 3 gamma of 3 dx. Gamma of 3 equal to 2 factorial. That's equal to 2 power 3 equal to 8. Then the probability of x greater than 12 equal to 1 minus the integration from 0 to infinity to 12 of x power 3 minus 1 times e to the minus x over 2 over 8 times 2 dx, then equal 1 over 16. Because this is constant, I will get out the integration 1 over 16. 1 over 16 of x power 2 e to the minus x over 2 dx. Then I will find this value of this integration. This integration, I will use the table to find the integration. You can use another method, like the integration by parts, UDV. So I take the table method. I will take the symbol function x power 2 by the column derivative and the e to the minus x over 2 in integration column. Then I will derivative this function to get 0 and integrated this function to and stop when I get 0 in another function. Then the probability of x greater than 12. So I will multiply the value of function, this x power 2 times the minus 2 e to the minus x over 2, and we start from the sign positive and the next sign negative and positive, so on. Then I will multiply x power 2 times minus 2 e to the minus x over 2, 2x times 4 e to the minus x over 2. So we must don't forget the sign minus, so on. 2 times minus 8 e to the minus x over 2. Then the probability of x greater than 12 equal to 1 minus 1 over 16 times the bracket 2x power 2 e to the minus x over 2 from 0 to 12 plus 8x equal 8x times e to the minus x over 2 from 0 to 12 plus minus 16 e to the minus x over 2 from 0 to 12. Then we substitute the value of 12 and 0 to find the result of the integration. 1 over 16 times minus 2 times 12 power 2 e to the minus 12 over 3 minus 0 minus 8 times 12 over 2 e to the minus 12 over 3 minus 0 plus minus 16 times 12 power 2 e to the minus 12 over 3 plus 16. Then the probability of x greater than 12 equal to 1 minus 1 over 16 times 6.7196, then equal 1 minus 0.41997. Then the probability of x greater than 12 equal to 0.58003.